Oh, nice. It's so fancy. So fancy. Awesome. Thank you, Zach. Alrighty, so today we are starting sort of in a different world than what we've been doing. That information you learned, modules 1 through 5, is not going to go away. We're still going to lean on that. You're still going to see some concepts from the first few modules pop up. But we are doing some pretty different stuff, at least for the next few weeks. We're going to start doing a lot more web-focused development, a lot of web stuff. So today, if you did the prep work for today, which I hope you did, you learned a lot about kind of how the internet works, how networking works. And so that's what I want to talk to you about today. I've got some demos for you today of stuff that I want to show you and some other fun things that we'll talk about. Before we get there, though, let's just do some review of stuff that hopefully you learned about when you were doing the prep work. So what's an IP address? Somebody tell me what an IP address is? Yeah. Yeah, exactly. So we've all used the internet, right? I hope. So, you know, when I request a website or I send an email or check my Facebook or whatever, it has to know how to get that information back to me somehow, and that's an IP address. It's an address, called an address for a reason. It is a way to locate myself, a way to locate me. How many are there? How many IP addresses exist in the world? Yeah. About 4 billion, right? Which seems like a lot, but actually, if you think about it, there's a lot more than, there's what, 7 or 8 billion people on the planet? I forget the exact amount. But not only that, how many electronic gadgets do you have? I have a laptop, I also have a phone. I've got another computer in my office at home. I've got some other gadgets at work that can get on the internet, right? So I'm hogging probably a few IP addresses, just me, just myself. And maybe I'm an extreme case. You know, I work with computers as part of my job. But even still, we're running out of IP addresses. It's sort of become a problem. You may have heard about it recently, that we're kind of out of IP addresses, actually, as a matter of fact. So we've had to use some creative strategies to leverage the ones that remain. But eventually, they're going to be gone for good. And we're going to have to switch over to a new form of IP addresses called IP version 6, I believe. We're currently on IP version 4. Don't ask me what happened to IP version 5. I honestly don't know. I'm sure it exists. It must have been bad. I don't know. But we're not using that one. We're skipping that. We're going straight to 6. If Microsoft can skip straight to Windows 10, then surely we can skip to IP version 6. So how many of those are we going to have? Does anybody remember? It's a big number. I'm not sure I even know what the exact number is. It's a lot to keep us satisfied for a very, very long time. So you've probably heard or seen stuff about that in the past. I haven't heard much lately, actually, but a few years back, there were a few calls for people to switch, make the switch from version 4 to version 6. A lot of websites, I think, actually do accept version 6 IP addresses these days. So 1 point for humanity there. We figured that one out. What's DNS? What's DNS? Yeah. Domain name service. That's exactly right. Why do we need it? What's it for? What's the big deal? Yeah, so everything on the internet can be referred to with an IP address, right? An IP address is an address that tells us where something is, how to get somewhere, right? So when you go to Facebook, that's actually taking you to an IP address. In fact, it needs the IP address. When you go to Google, it needs Google's IP address. I don't know Google's IP address. I don't want to know Google's IP address. What's easier to remember, a string of 4 digits or Google? Google is much easier to remember, right? For people, we do better if we can use, human language, human words, to remember things instead of these numbers with dots in the middle. So we use DNS to kind of make that mapping. I give you a name, but I can't go to that website just based on the name. I need the IP address. So what's the IP address? Well, I go to what's called a domain name server, and I look it up. So I give you google.com, and it tells me, okay, Google's at this IP address, and now I can successfully connect to that IP address. So you can think of it as very much a convenience factor in a lot of ways, but it's very important. It's very important. In fact, if a web page goes down, in fact, I think we might have even had this problem with our LaunchCode website. Well, it takes time for those connections to take place. So when we create a website, launchcode.org, it takes time for that name to be associated with the IP address, especially when you figure IP addresses could be reused. So maybe the IP address that we have now was, some other website a few months back. It takes time for that information to propagate throughout the internet. There's a tool called Nslookup that you can use. In fact, you should be able to do this right from your IDE. If you want to know the IP address for any website, you can just run it through Nslookup, and there's the IP address for Google, actually several of them. Not surprising that Google has several. It's a pretty popular website, I'd say. So not surprising that it's got several IP addresses for people to access. But you can use Nslookup to then tell you what that IP address is. Okay. Cool. Okay, what's a router? Can somebody explain to me what a router is? You've all probably got one in your house. Routers are those things that were failing the first few weeks of the class, right? That's what a router is. So what's a router for? Yeah. Sure. A connection hub? Yeah, I like that. You might hear it referred to as a gateway. Router, gateway are often kind of synonymous with one another. So a router is kind of your access point to the internet. Consider we're all inside this building. We're all on the same network. We're all on LaunchCode's Wi-Fi, right? But all of those Wi-Fi, all that Wi-Fi that we're all connected to right now, in order to get to the internet, in order to go to Google or Facebook or whatever it is that you guys are looking at right now, instead of listening to me, you have to go through a router, which you can see some hanging on the walls. Well, they've actually done a pretty good job of hiding them. A router is kind of your gateway to the internet. So when you visit a website, when you say, hey, I want to go to Google or I want to go to Facebook, you send out that request, and the website actually sends it back to the router, and the router remembers who on that local network made that request and routes it locally. So there's kind of a layer of protection there. The router does give you some sort of protection. It's sort of like a gatekeeper in some sense, right? It's not going to let anything through. It's going to make sure that, somebody on the network actually asked for this thing instead of just blindly letting anything in. That's a good thing, right? Because there's all kinds of crazy, weird stuff flying through the internet, and we don't want all that junk. We just want to check Facebook, right? If you're interested, in routing through the internet, there's a cool little function called traceroute that can, show you how the traffic is flowing through the internet. So in Windows, I spelled it wrong, I think, trace-rt. In Linux, it's traceroute, actually spelled out, R-O-U-T-E. And then I believe you just type in an address that you want, like google.com, and it'll show you where this request is going to, because it's not just going directly to Google, right? There's a lot of stuff in between. There's a lot of stuff in between me and Google. So you can see here, this is probably my local address on the Wi-Fi network. This is probably the router. And now we start getting out, so that one says St. Louis. That's probably Charter Internet's hub somewhere in the city, and then it's shipping it out to Chicago. I'm sure Google has servers in Chicago. Who knows what these are? I don't know what those are. Just some IP addresses that we had to go through to get to Google. Don't know what they are. Not a whole lot of information. But then, hey, we finally made it. Finally made it to Google. So you can see that when I send that request out, it's not just a straight line. It's not just point A to point B. It's going to the router, and then to the outside, and then all the way to Chicago, and then to somewhere else in Chicago, and then somewhere else in who knows where, and then Google. And then all the way back, right? It has to go all the way back, too. Cool. So that can be a fun little thing to play around with, fun little tool. It can also be useful if you're trying to hit a website and it fails for some reason. You can run a trace route on it and see exactly, at which point, how far do I get before it fails? Can I see my router on that list? Then I know it's not my fault, right? I know I don't have to reset the router. Might be something on there. And if I don't even get past the router, well then, hey, maybe I need to reset my router or do something else. Alrighty. What's TCP? So we already kind of talked about IP, but you often see them together. What's TCPIP? Transfer Control Protocol. Yeah, so what's it used for? Right, yeah, so this gets into a whole big can of worms about networking. So when we send information across the internet, when you are looking at cat pictures through Facebook or whatever, is it sending that cat picture as one giant chunk of data, just boom, here's your cat picture? No, it's not. It's not. Why not? Why doesn't it do that? Clog the tubes. Clog up the tubes. There's lots of people looking at lots of cat pictures. We don't want to slow things down. So what it does is it breaks it up into chunks. It breaks it up into small chunks because it's a lot faster to pass those chunks through. But the issue then is, okay, I've broken it into small pieces. How do I know when I've got all the pieces? How do I know when I have all of those pieces of my cat picture? And then how do I stitch them back together, right? So that it's actually the thing that I asked for and not just a bunch of random garbage. So that's kind of the problem that TCP/IP was designed to solve. So what's a hop then? These are all kind of related to TCP/IP. What's a hop? We actually just saw it. I ran a demo a little bit earlier. Yeah. Right, so when you saw me run traceroute a few minutes ago, right, and it went from here to the router to somewhere else to somewhere else to somewhere else, those are all hops. Those are all different hops. And so ideally, we want to use as few of those as possible. We want to choose the shortest path possible. How do we choose where it goes? We noticed ours went to Chicago. Why didn't it go to Chicago? Why didn't it go to San Francisco or Japan or somewhere in Europe? Well, there's a whole bunch of routing tables out there that say if you're trying to get to this address, you should go this way. Think of it as like signposts, right? So every router, every switch that's out there on the internet is kind of like a fork in the road. It looks at where you're trying to go and it says, well, you should go this way. You should go this way. You should go this way. What's a packet then? What's a packet? Yeah. Yeah, so when we use the picture example that I was talking about just a few minutes ago, we chop it up into pieces. Those pieces are packets. So the packets are the actual data, but the data contains some information along with it, such as how many packets are there? How many chunks? Which chunk is this one, right? Is it the first chunk? Is it the last chunk? Is it somewhere in between? So which one is it? Stuff like that. What's a port? What's a port? Yeah. In a lot of cases, sure, yeah. So what kinds of things do we see ports used with? What kinds of stuff? Yeah. Yeah, email, file transfer, even browsing websites, right? Websites use which port? 80, usually, not always, but usually. You can think of ports as also being similar to a doorway, right? Or maybe, I don't know, maybe a better example might be one of those things where you've got the holes and you need to put the pegs of the right shape into the holes, you know what I'm talking about? The port needs to, if I'm sending browser data, HTTP data, it needs to go in the right port, or it won't be accepted by the end system. What about a firewall? What's a firewall? Yeah. Yeah, so it can definitely block by IP addresses. So if you got some guy trying to pull some funny business, you can just say, I don't like you, I'm not going to listen to you anymore. So a firewall can do that. It can also block certain types of traffic. So, a lot of times at large businesses or at work, they won't want to accept certain kinds of traffic. There might be security risks, or maybe they just want to make sure their employees aren't watching too many YouTube videos at work, right? Firewalls can be set up to reject certain kinds of traffic as well as absolute destinations. And then what's a VPN? Virtual private network. Virtual private network. So how does that work? It sounds like something super fancy, but it's really not that difficult of a concept. Yeah. Right, and it kind of obscures where you're coming from. So if I'm using a virtual private network, I'm going to have a very dedicated encrypted connection between me and somewhere else, usually in a different part of the world, oftentimes. And then anytime I go to a website, or anytime I check my email or check my bank account balance or whatever, it's going to look like that the request came from that other place over here. It's not going to look like it came from me directly. So it kind of obscures where you're coming from. So, a lot of these things have to do with security. We're actually not going to get too heavily involved in security in this class, but security is very important, especially on the web, so I thought it would be useful to cover some of those security-related concepts, even though we're not really going to mess with a lot of that stuff directly. Cool. Any other questions about this stuff before we move on forward? Yeah. Well, the connection between you and the VPN is typically encrypted, so anything that's sent from the VPN to you and vice versa is unreadable to the outside world, to a large extent, yes. There's a lot of details that go on with VPNs, actually. We gave a very sort of high-level introduction to it, but it's a very important concept, very useful tool. I use them for work all the time. A lot of people use them for work, right, because maybe they have some confidential material that they don't, shouldn't be seen outside of the business, outside of the company. Well, if I need to access that when I'm not at work, maybe I'm at home or something, I can use a VPN to build an encrypted tunnel between me and my company's server, and then I can access any of the data that way. And then that data is actually not exposed to the outside world. The only way that I can get to it is if I tunnel in, right? So I kind of have to go under the fence to get to that data, if that makes sense. Cool. Any other questions? Great question. Yes? So DNS, as we said, is used to take an IP address and associate it with a name, a more human-friendly name, right? DHCP was also mentioned very briefly in the prep work, is used more to assign you a local network address. So when you get onto the router, the LaunchCode router, right, it needs to give you an IP address so that it can send stuff to you. So how does it know what IP address to assign? Well, it's got a whole pool of addresses that it can choose from. So it just picks one out of that pool and it gives it to you. But it also doesn't really know how long you're going to need it, because a lot of you, are going to use it for a few hours while you're here, and then you're going to go home, and we want to get that IP address back, right? So DHCP, what it does is it assigns you an IP address on a temporary basis. It says you can have this for a day, or a few hours, or in some cases even just a few minutes. And then once it expires, it'll try and reach out to you and say, hey, are you still using this? Do you want to keep using it? Do you want to renew your network address? And if you're still online and you're still able to talk to the router, you'll say, yep, I'm still here, I'm using it. If you're not, then it'll say, okay, they must have left, I'm going to take that IP address back and let somebody else use it, eventually. That's DHCP, yeah. Great question. Any other questions? Yes? A standard size for these packets? Yeah, actually there is, as a matter of fact. There's a maximum size typically for these packets. We will see that actually in just a little bit, but off the top of my head, I think the standard size is, it's smaller than you think. Maybe, I want to say like, yeah, thank you. That was the number that was in my head, 1,500. Thank you. Any other questions? Great questions. So 1,500 bytes, that's not a lot, right? How big is your average cat picture? A lot bigger than 1,500 bytes, probably. A lot bigger. That's, a little over a kilobyte, right? It's not a lot of stuff. It's not a lot of stuff. Okay, so TCPIP, the prep work didn't go into a huge level of detail, but I wanted to talk to you about it in a little bit more detail than what they presented in the prep work. You might hear references to the TCPIP stack. There's actually 7 layers. So every time you send something across the internet, whether that be, checking a page for whatever reason, or sending an email or something like that, it goes through all 7 of these layers. It goes through all 7 of these. The layer that we're most familiar with is the top one, the application layer. That's your browser, right? That's a web browser, for example, or anything that is showing you information from the internet. That's the application layer. The other layers we don't see as often, but they're at least not in front of our faces, but they're very important. So presentation layer is going to deal with encryption, right? Encrypting data, which is of course very, very important for security purposes. Sessions are something that you might have heard. So if I want to communicate across an extended period of time, I might open what's called a session, which keeps that window open for longer. TCP itself, the protocol itself, deals with the transport layer. So do I have all the packets, right? What order do the packets go in? That's TCP's job. The IP address is actually moving things across. So the trace route, when we saw trace route, that was the network layer. So what path I'm going to take to get from here to Google? And which places do I need to hit along the way? That's the network layer. And then when we get down to the bottom, the data link layer and the physical layer have to do primarily between you and the router. So how am I physically going to transmit stuff? Is it going to be across a wire? Is it going to be across the Wi-Fi, right? So here we're talking very low level. How am I literally transferring the ones and zeros from me across the network? That was a very high level, kind of watered down version of it, but it's a very famous, very useful way of talking about networking and the internet. This idea of a TCP IP stack. So if networking is something that's interests you, if you did the prep work and you thought, hey, this stuff's pretty cool, I want to learn more about it, I would recommend this as a good entry point to learning about the world of networking. Just kind of working your way through these different layers and trying to understand how they all work and how they all interact with each other, right? Any questions? Yes, Zach. Yes. So if I try to go to Google right now, right, it's going to take one path. But if I come back tomorrow and I try again, it might take a different path to get there, or it might even change in 5 minutes. Probably not. It usually takes a little bit longer than that, but. Wrapped unchanged. So TCP and the network layer they go hand in hand, right? One layer by itself cannot do the job. They work together. So TCP, the protocol itself, is a series of acknowledgments. I sent you these packets. Did you get them? Yes, I got them, right? And then, okay, I'm done sending you packets. I have nothing else to give you. Okay, that's cool. I'll, stitch everything back together and give it to the user. That's TCP. IP is literally, I want to go here. How do I get there? So you need them both. What? Does it change each hop? So our routers here, they probably aren't looking any farther than the very next step. So when it ships it off to Charter's servers here in St. Louis, it has no idea where it's going to go after that, and it doesn't care. All it sees is a packet coming through that needs to get to Google, and so it just says, you need to go this way, and then it's done. Its job is over. But it does there's a lot more advanced stuff that's going on. For example, you can get heavy amounts of traffic across certain parts of the network, in which case you might want to avoid those, right? You might want to route around them. So IP does have mechanisms in place for avoiding high traffic areas, or say something fails for whatever reason, it just goes down. Can I find an alternative path to get there? IP does have those kinds of mechanisms in place. It's really treating one hop at a time. There's nothing that's really looking at the entire path as a whole. Yeah, it's just one hop at a time until it eventually gets to its destination. You can think of it in a lot of ways as like driving from here to somewhere very far away. Let's say I want to go to Chicago. What am I going to do? Well, the first thing I need to do is get on the very small local roads out here, right? And then I might hop onto Grand, which is a bigger boulevard with more traffic. And that'll take me to 64, which is just a massive highway, which is handling lots of traffic. And then eventually I get to Chicago, and I do the same thing in reverse, right? I go down to the smaller roads, and then eventually I end up at my destination. You can think of routers as very much the same way. Well, if I have an address, right, then I can figure out how to get there. The same is true in person as well as IP addresses. I feel like I might be misunderstanding your question. Yeah. No, it's really just focusing on the next step at a time, not the entire path. It's hard to say, it's hard to give a blanket statement because there are many different ways of routing things for all kinds of different purposes. But in general, you're looking just at the next step. Each router is only concerned about where the packet needs to go next. Once it's left, once it says you need to go this way and the packet goes that way, it doesn't care what happens to it after that. It's not its problem anymore. It's the next router's problem after that. And so one thing that we haven't talked about yet, right, is this idea of guarantees. There is a guarantee if I send something over the internet that it will make it to its destination. That's what TCP is for, is to give us that guarantee. It uses those acknowledgments. Did you get this? Yes, I did, right? But packets don't always make it. They don't always make it to where they're supposed to go. Maybe they get rerouted the wrong way for some reason, or maybe it's just taking too long. You've probably seen timeout messages. The connection's timed out. That just means it was taking too long. I don't know where this packet is. It got lost. Eventually, packets will just kind of fizzle away. They'll kind of disappear. They'll be like, oh, I've been out here for a while. I still didn't make it where I was supposed to go. I should probably just give up. So you can and will lose packets often on a regular basis. What happens? Well, TCPIP says, hey, did you get this packet? And then you say, no, I didn't get it. And so it says, oh, okay, I'll just send it again. And it'll keep trying to do that until it actually guarantees that you receive every single packet that it needs to send. Not every protocol will do that. Some protocols say, hey, you lost a packet? Whatever. Oh well, deal with it. But TCPIP guarantees that they all make it there. Any other questions? Great questions, by the way. All right, a few more review questions, and I do have a couple demos for you today as well. What's HTTP? What's HTTP? Yeah. Hypertext Transfer Protocol, exactly. Yeah. So what do we use it for? What's HTTP used for? Sure, getting websites. That can be done. Yeah. Yeah, so it's the primary mechanism for browsing the internet, for browsing the web these days, right? So what are some kinds of requests that HTTP can use? What are some examples of HTTP requests? Yeah, get, so that's probably one of the most basic ones, right? Give me this page, let me see it, right? What else? Post, what's post do? Yeah, so post is whenever I need some additional information to retrieve a page. Hey, I want this, but here's my credentials so that you can see that I have the ability to actually look at this thing, right? Or not, whatever the case may be. Or, here's my information, create an account for me, right? That's a post. I need to send some information out from my end. What's curl? You guys play around with curl at all? No? So curl is kind of a throwback to when we didn't really have browsers so much and we just had a command line interface. Curl allows us to pull stuff from the web via the command line. So most of the time when we want to see a web page, we just open up a browser. We open up Chrome or whatever, and we just type in the address, and we go to that thing, and the web page pops up. But we can also request websites through the command line using curl. And it works much the same way. The difference is, on the command line, I can't see pictures, I can't see videos, all I can see is text, right? So when I use curl, I'm not going to see videos or anything extra. I'm actually going to see the code. I'm actually going to see the code that the website consists of. We'll see some examples of that in just a little bit. So then what is a server? Yeah. Yeah, so it contains the content, right? A server contains a thing that you want people to be able to access somehow. So you can think of it as all being in a centralized location, and then we're going to wait for people to come to us, right? So that's what the clients are. We're all clients. Anytime you hop on a web browser and you go to a website, you are a client. You're using a client, a browser, to connect to a server that hosts that particular website. And then what's HTML? Yeah. Hypertext markup language, that's actually a big topic for Thursday, so I'm not going to dive too much into that today, but all websites use HTML in some form or another. It's what gives our pages structure. So we're going to talk a lot more about that on Thursday. Any questions about this stuff before I show you a couple of demos to kind of wrap things up today? So I do have some fun demos for us to play around with. Let's see what I've got. Yeah, so before, I wanted to give you kind of a brief history of the internet, right? This is, so ARPANET is how the internet started. Any idea when that happened? What year are we talking about? 78? No, it goes back farther than that. Yeah. 50s, I think it was 60s, maybe late 50s. 60s is what I was thinking. But yeah, that's the right ballpark anyway. 50s, 60s is when ARPANET was first being developed and forming. Now, ARPANET was very much like the internet as we know it today. The biggest difference is there just weren't as many things on it. So a lot of major universities, it was actually by the Department of Defense in the United States, so a lot of military bases had access to ARPANET. But we're talking of about maybe dozens of places that you could go. So imagine if the internet had 15 websites or 20 websites on it, and that's it. That's ARPANET, right? Not only that, but we didn't have browsers or anything like that either. No videos, no pictures. It was all text, all text-based. So after that was telnet. Telnet was sort of an evolution of ARPANET. Actually, you probably can't do anything with ARPANET these days, but you can still telnet these days. It's not installed by default anymore on Windows, but it does still exist if you want it to on Windows. And so I like to show people a little example of what browsing the web may have looked like back in the day. So I type in an address, and I tell it to go, and it'll start loading stuff up. Let me see if I can make this text. Can I make this text bigger? Oops. I did not want that to happen. Oh well. So this is a website of sorts. You'll see what it's doing in just a little bit here. don't know if you can read it, but it is quite literally the entire movie of Star Wars being hosted in ASCII, delivered over telnet, which is how things were delivered across the internet long, long ago. We're up to maybe about the 70s now. It's the whole movie. It's the whole dang thing. If you want to sit down and watch it sometime, I kind of already know how it ends, but it's fun. It's pretty neat. Somebody spent a lot of time on this, so it's pretty good. It's pretty good. Yeah. So you can imagine, maybe, there we go, R2. You can imagine, man, if you wanted to access a website back in the 70s, they probably didn't have this back then, but it would have been, text in this form. That's all we had. We had text. Yeah, that's it. 69. Okay, so the 60s, yeah. Telnet was afterwards. Yep. All right, sorry, I gotta stop. I gotta stop. So then TCPIP came along. It actually came along, it's been around for a relatively long time in terms of computers, around the late 70s, early 80s when it first came out, and that really changed the game. From there, we were able to create browsers. Anybody know what the first browser was? It's not one that we have today. I think it was Mosaic. It's actually made at the University of Illinois, right up the street in Champaign-Urbana. Yep. So browsers came along. Everybody kind of remembers when that happened, right? That was sort of mid-90s, mid to late 90s. And it gave us stuff like this that you can still find. For example, the Space Jam website still exists. It's got some great stuff on it. This is from the mid-90s, one of my favorite. Oh, no Space Jam used at the moment. That's too bad. Or this website, Internet Explorer is evil. We all remember websites like this, right? With the GIFs in the background. Here's a nice one explaining how to make a blowtorch using strawberry Pop-Tarts and a toaster. You can see the pictures. And then this one's actually probably my favorite, good old Dolcamp 96. Yep, still online, still up there, yeah. Website lasted way longer than their campaign did. Yeah. So that was the internet that most of us met, right, for the first time. And when most of us were exposed to the internet for the first time, that's what we saw. We saw pages like this. And this was pretty basic. We could do HTML, we could do pictures, you see pictures. Video, not so much, not so much. We kind of tried to emulate video by using these GIFs, these moving pictures of sorts, right? But that's not really video necessarily. So things have changed a lot since then. Al Gore invented the internet in 1999. And then we really took off in the early to mid 2000s when we introduced some really useful web programming based constructs, and some of those we're going to learn in this class, like PHP, a programming language that gives us programmatic control over our websites. I believe PHP was around before then, but that's when it really started to take off. Question, yeah. Say that again? They both stand for HTML, yeah. The only reason HTM exists is because Windows used to not be able to have file extensions longer than 3 characters. They've since removed that limitation. Yeah. But yeah, so things like PHP and JavaScript really started to take off, and that really opened the door to the modern websites that we're used to looking at today. So you can see the user interface has really expanded, and that's kind of what I'm excited to show you about in this next module, and the one after that as well, is how to do some more modern stuff on the web. We're not going to make pages that look like this. Well, maybe at first we will, but then we'll make some better ones later on. I made websites that looked much worse than this back in the day. I hope they're gone. I hope there isn't some guy somewhere else right now showing my web page and being like, look at this garbage. But I would deserve it. Yeah. All right. So to kind of wrap things up, I wanted to show you a couple of other neat little things. So what exactly happens when you visit a web page, right? What actually happens when you type that address in and you hit enter? Well, there's a nice tool out there called Wireshark. Wireshark is a packet sniffer. So what that means is it's going to watch all the traffic going into and out of your computer. Everything. Every single packet that's sent, every single anything that's being sent over the network, it will see it. So you can imagine that this has, you know, some potentially nefarious purposes, but a lot of security researchers use it as well to see, you know, what kinds of things people are doing on their networks. So I wanted to show you, you know, what actually happens when we visit a web page. Let me pull up LaunchCode's web page real quick, something that we're all familiar with. Right? So here is LaunchCode's website, and here is Wireshark. I was actually playing around with it a little bit before class. So I'm just going to give you a quick demo of kind of how it works and show you what I'm really more interested in is using this to show you what happens when I actually type something in and go to that website. So what I'm going to do is I'm going to tell it to start capturing packets. It's not doing anything right now. But I'm going to tell it to start capturing packets, and then I'm going to switch over to the browser and do a refresh on that page, and then tell it to stop. I'm going to tell you all this now because I want to do it kind of quickly, because I don't want to capture anything more than just that one process. So I'm going to start it. Continue without saving. I'm going to go over here. I'm going to click refresh and let the page load, and then I'm going to come back and I'm just going to tell it to stop. And so when I went over and I clicked refresh, or when I go to the bar and I type in an address and I hit return, what am I doing? What am I telling my browser to do? We've talked about it today. It's sending out what? It's sending out an HTTP request, right? It's sending out an HTTP request. So if I want to find that request, I can type HTTP in the box up here at the top and have it filter by HTTP requests. And then I see right up here at the top, oh, hey, that one says CS50 St. Louis. That's probably it. That was probably the request that I sent out to get that web page, right? You can see that once it satisfied that request, there's a whole bunch of other ones after it. Well, I didn't tell it to do those. But what are these? These are CSS. So when it loaded that web page, it said, well, I can't show this web page to you properly without getting this extra stuff. So I need to send out requests for those things as well. And that's what you're seeing right here. So once it sends it out, what protocol is it using to send information back and forth between me and the LaunchCode website? TCP, exactly, TCP. So if I really want to see, you know, the data that's being sent back and forth, I need to look at TCP. HTTP is just a request. HTTP is just me saying, hey, give me that website, please. No data, well, a little bit of data. If you look down here, you can actually see the request. It says, you know, this is what I want. This is the website that I'm looking for. It's probably got my IP address in here somewhere. There's some few other options, right? But if I actually want to see the data, I need to look at the TCP packets. So to do that, I can actually right-click this request and go down here to follow, and there's an option for TCP stream. So this is going to show me all the TCP packets that were sent as a result of this request. So if I click that, it actually shows me this is all the data that was sent over TCP, and then right here is our beautiful LaunchCode website, but hang on a second, that looks kind of like a bunch of junk. Oh, it's kind of weird, right? That is, in fact, the website. That's all the CSS. That's all the HTML. That's everything else. Why does it look like this? Why doesn't it look like something that we can recognize? It might be encrypted. It might be compressed somehow, right? So chances are it's probably not just sending it straight across the wire as is. It's probably encrypting it or compressing it of some sort. So I can't recognize it directly. I can recognize it in the browser, because the browser can undo that process, but Wireshark is not undoing that process. I'm looking at encrypted or compressed data right now. But it does show me all the packets, and I can actually look at, here's a list of all the packets that were sent. So you can see the ones that are marked TCP, right? And you can look at all the stuff that was in that packet. It tells you how big it was. So here's the length. It's about 1450, so roughly 1,500 bytes, like we were saying earlier, right? It should say, you know, should give some ordering information, such as which packet am I, right? So frame number 424, let's see, that's not what I'm looking for. I'm looking for, let's see, where is it going to show me? Total, well, that's the length of the packet. Where's it going to show? Oh, here it is, TCP down here. So source port, there's port 80. It's a web request, so that's the port that we would expect, right? Port 80. It should show some information about the IP addresses and stuff like that. Sequence number, so there's the information. Which packet is this in this particular sequence? It says 6,431. There might not actually be that many packets, but that is the sequence number that this one belongs to. Right. If we want to try a different example, where we can actually see the results, we can use my personal website for Washington University. There's a very outdated picture of me where I don't have. If we try Wireshark with this one, encrypted or compressed, so we can actually see that it works, perhaps as you might expect. So I can just refresh this real quick, let Wireshark pick it up. Oh, come on. That took longer than it should have. And then come back and stop and repeat the process. You know, just look for the HTTP. Here it is. That's my website. So if we look at the TCP packets now, hey, that I can understand. There's, you know, my short little bio, all the HTML for my personal web page, right? So you can see the actual data that was sent across those packets. The interesting thing about Wireshark, if you are installing it, as I imagine some of you probably did when I mentioned it, if you just turn it on and you don't do anything, right? I'm just going to turn it on. And I'm not touching it. Oh wait, I should clear the filter. Sorry, clear the filter out. It's loading a bunch of packets. I'm not doing anything. And look at all the information that's going out. Now, part of that is me streaming this video to YouTube right now, right? But not all of it. Not all of it. If I stopped my YouTube streaming and I came and I said, tell me what packets are going through, my computer is talking to the internet all the time, whether I tell it to or not, right? So what is it for? I honestly don't know. I have to look into it, but it's an interesting thing. It shows you everything going into and out of your computer. All righty. Any questions on that? I got one more demo for you to wrap up today. Questions? Yeah. Encryption is, I don't want anybody but you to see what this stuff is. Compression is, I'm going to shrink it so that it takes up less space and hopefully goes faster across the network. So I have less stuff to send, so it should get there faster. So compression offers no security. Anybody could potentially intercept those and just decompress them and see what you're saying. Encryption is nobody can see what this is except for you. They're often used in conjunction with one another, right? Yeah, compression has no keys. Encryption does. Yeah. Compression offers no security benefits whatsoever. I mean, the algorithms are a lot different. Yeah, a lot different. Any other questions? I thought I saw another hand somewhere. Yes. I don't know. Good question. Somebody want to Google it for me? Let me know. I don't know. What? RTMP? He asked what RTMP was, and I don't know what that protocol is. Okay. That's a very not descriptive name, real-time network protocol. Very generic sounding. Actually, it might astound you to see how many different kinds of protocols there are. If I go down here, there's an option for enabled protocols. I'm only on the B's. right? Look at how many protocols there are. It's insane. There's a bunch. There is a bunch. A lot of these are rarely used, rarely if ever used. You know, the big ones, HTTP, TCP, you'll see those just about everywhere. Okay. Yeah, Wireshark is a great way. I mean, that's a rabbit hole. If you're looking for something to kill an afternoon, download Wireshark. I've spent many an afternoon just kind of poking around, seeing what all's going on. It's also potentially scary to see, you know, just that you can do this, right? That's kind of scary. But thinking about what other people might be using this for also potentially scary. Security is important, very important. Any other questions before I move on to my last demo? So we kind of went off on the side. We kind of took a little deviation there. But I do want to bring it back around to stuff that's more relevant to the coursework that we're going to expect you to do for Module 6 and Module 7 and 8 as well. So to kind of wrap things up today, this is directly applicable actually to the studio that we're going to ask you to do here. I want to introduce you to this concept of an API. Is anybody familiar with an API? I don't think it was on the prep work today. Anybody familiar with an API? Yeah, can you tell me what an API is? Application Program Interface. So what does that mean? Can somebody tell me you know, what an API is, what it's used for? Yeah, you're back. So somebody builds a program, and it does some stuff, and it does it really well, right? And other people probably want to use it. There's no need to redo the work that they've already done, right? I can just use their thing, if they're kind enough to let us, right? If they do want to let us use it, chances are they're probably not just going to hand over everything and say, here you go, have fun. Well, they might, but they might not. Another way that they can do it is, say, provide some interface to that application. So if you do this, it will give you back this piece of information. And that way, I get what I want. I get to use the application, and they kind of get some protection. They don't have to show me how it works. They don't have to show me what's on the inside of the application, but they do allow other people to use it, right? So APIs are all over the place, all over the place. In fact, you probably use them every day. You just maybe don't realize it necessarily. One company in particular has probably the most widely used APIs in the entire world. Anybody have a guess as to what that company might be? Yeah. That wasn't the one I was thinking of, but that's definitely up there. Google, I was thinking about the Google, yeah. Google has a massive amount of APIs. They do lots of stuff. I'm just going to show you one. They literally have dozens of different applications, of different APIs that you can sign up and use for free a lot of times. Sometimes you do have to pay. So how does it work? Well, with an API, I have to send a request. I have to send a request like the request we've been talking about, right? It's going to be an address. It's going to be an address. And then I have to provide it with the parameters of the request. So every API should come with documentation explaining, you know, what the kinds of things are that it can use. Here's one Google API. Let me see if I can make this a little bit bigger. It shows, this is a custom search API. So Google searching, that's kind of their main deal, right? So there's a way that you can access Google search without necessarily having to go to google.com and type a search into the website. Where might you see this used? If you ever go to a different website, a not Google website, and you see that they have a search box on there, they could be using Google, right, to provide their search. That's a classic use of an API. So this is really not the way you should be using an API necessarily. This is more for testing purposes. It's just kind of a little taste. But it does show you what the API can do. This is the query. What do I want to search for? What do I actually want to search for? This is the search engine that I want to actually search on. So I can create different search engines that restrict my search results to only a certain set of websites, for example. Or maybe I just want to search the entire internet, for example, right? So this is a very long value that just says, what do I want to search from? If it's from my own personal website, this search engine might just be search my website, right? I could do that. This one happens to point to the entire internet, everything on the internet. You can see a lot of other options here that are not filled in, right? Date restrictions, file type, all kinds of stuff. Images, you can do image searching, right, through this API as well. So lots of options that I'm not going to use. In fact, really the only ones I'm going to use are the pretty basic ones. I want to search for launch code across the entire internet. Maybe not the most exciting search in the world, but I provide those to the API. I click this big button down here that says execute, and then it will send me, here it even shows you the HTTP request that it used, right? And then it shows you the results. So here are my search results. It's got a bunch of information. This is in a format called JSON. Have any of you seen or heard of JSON before? You're about to see more JSON, probably today in the studio. The way to think of JSON is kind of like a map, actually. Remember those hash maps that we had you messing around with? These are pretty similar. This is my key, and this is my value, right? So it's just a list of key value pairs, right? There's some syntax involved. I need the quotes and the colon and all that stuff. But you can start to decipher, what this information is actually doing. Once we get down to the search results, items, this is what's telling us what the search results are. Very first hit, launchcode.org. Well, that makes a lot of sense, right? If that would be the first hit. I hope that would be. If we keep going down, we should see another hit. It says Facebook page. All right, so LaunchCode's got a Facebook page. We keep going, apply to LaunchCode. That's actually LaunchCode again, it looks like. So if we keep going, it looks like we've got some images and stuff associated with these. So lots of stuff pointing to LaunchCode's actual website, which is what you would expect. Wikipedia, another classic search result. So this is what you would see if you went to google.com and you typed in LaunchCode, but in a form that's maybe more what the computer is dealing with as opposed to what you see as a human, right? This is kind of what the computer is dealing with every time you look at those search results. Yeah. Jobs, lots of stuff. Oh, here's an article from the Miami Herald. Cool. Jim McKelvey. Q&A with Jim McKelvey, right? So lots of cool stuff about LaunchCode, or whatever query that you want. So I use this sort of form that they provided, but if I didn't want to do that, if I wanted to put this in my own application, I could form the request myself. Just like the requests that we've been forming for other stuff, I have an example of that exact same request. Let's see if I can make this a little bigger so you guys can see a little easier. Of that exact same request, right? This is the website where we access the API, googleapis.com. This is the API that I want to access. So custom search. You can think of that as like a folder on this website. Just like we have folders on our computers. This is very similar to like a folder or a directory, but on a website. And then I need to pass in those parameters. So what do I want to search for? Where do I want to search for it? This question mark, whenever I see a question mark embedded inside of this request, that means I'm about to give you some parameters. I'm about to give you some options. Remember how we spent a lot of time talking about functions? Functions take input values. This is how I give input values to HTTP request. I say question mark, and then I specify what the name of the option is, equals, and then what the value of that option should be. So the query is right here. Q equals LaunchCode. That's what I'm searching for, right? This is that, where do I want to search for it? CX equals this long string of gibberish. There's another one that we didn't see before called a key. A key is a unique identifier. They want some accountability. They want to know who's using this. They want to be able to find people that might be abusing it, or using it for things that it shouldn't be used for. So that's actually my unique key, belongs to me personally, right? So that anything that I send through their API can be traced back to me. Please don't write that down, right? If you want to use an API, typically the first step is to sign up for one of those keys. Otherwise, you can't access the API. It's purely for accountability purposes, right? So I give it my key, I give it the search, the thing that I'm searching for, and I give it my query. And if I run this through curl, So I ran it through curl, I get the same results back that I just saw on the website. The difference is this time I could run that through a C program or PHP program when I learn about PHP in the coming weeks, or whatever I want. I can put this on my own website, run it through an application. Right? So APIs allow us to take something powerful like Google Search and use it in our own applications through Google. Right? You're going to get to see APIs today. You're going to be introduced to APIs today on the studio. Are there any questions for me right now about anything that we talked about? No? Yes? Yeah, so I mean, they have a Maps API. Maps are another useful thing that people use Google for. In fact, they've got tons and tons of APIs. Let me see if I can pull up. Here is a list of Google APIs. So they do a lot with advertising. So, oh, come on, computer. Okay. So they do a lot with advertising. So you see some advertising stuff. But then anything that you use Google for probably has an API associated with it. Some of these things I have no idea what they do. Never seen them before. Don't use them very much. But custom search API, that's the one that I was just using. Drive. So Google Drive, right? Anytime you make documents, spreadsheets, stuff like that, that has an API. Gmail, of course, has an API. So everything that Google does pretty much has an API that goes along with it. You can see how many of them there are. It's just an absolute lot of them. Google Plus, because everybody uses Google Plus, right? YouTube. So they have APIs for lots and lots of stuff. And Amazon, the other suggestions you guys mentioned too, Amazon, Facebook, they all have APIs as well that allow people to interact with their programs and with their code too. Okay. Any other questions? All right, well, if there aren't any other questions, that's going to about wrap it up for me today. So your next step would be to take a look at the studio. You're going to be messing around with an API, much like you just saw me doing up here. Right? And once you get that finished, go ahead and take a look at the prep work for the next class, and maybe even start poking around the PSET. And if you need to catch up on PSET 3 or PSET 5, that now would be a good time to maybe get some help and work on that kind of stuff too. So we'll be around. Let us know if you have any questions. Thanks. When would you not care about packet loss? I would. There are protocols that don't care about that. Yeah. So oftentimes those are used when the distances, I know the distances I'm traveling are pretty short, which means the packet loss is less likely in that particular case. There are some applications that can tolerate it, either because not every packet that's sent is useful information, or they might be able to recreate the information on the other side based on what they already know. Okay. In which case, that's faster than resending the packet in a lot of cases. So I don't actually know any concrete examples. I guess like chat programs. Have you ever used like instant messenger programs? Sure. Sometimes you lose one, right? Yeah. You send one and it just doesn't make it. Well, that could be lost packet. Okay. Because it's usually not, life changing if you lose a chat. Right. You can just say, huh? What'd you say? And then all of a sudden. Yeah. Okay. Cool. Yeah. Thanks. No problem. Hi.
So I have module 7. Okay. It is not posted yet, but I will be on vacation next week, and was trying to get ahead so that when I come back, I'm not like, where are we?
Okay. It should be posted by the end of this week.
Okay.
Yeah, by the end of this week it should be up. So probably by Thursday, actually.
I know I can work on the next problem set.
Okay. Yeah, the problem set's already up there. Harvard.
Yeah.
Good.
Yeah, I'm not sure what to suggest. You know, the deadlines are real loose,
Yeah.
so if you don't get to it till you get back,
Yeah.
it's
I just didn't want to show up at the house on the following Tuesday and be like, what's going on?
Yeah.
I don't know. I feel like the studio has helped me
Sure.
get everything.
Well, I mean, we do want to get it posted as soon as possible.
Okay.
So it'll be up in the next day.
Okay, perfect. I just didn't know. Then it says to be determined. I was like, do we not even really know what date?
Oh, we know what the dates are.
Okay, I was gonna. That was the other thing. I was like,
No, we know the
should know
dates.
some of this information.
Yeah.
Okay, so it's still gonna follow the same 3 days.
Yes.
Okay. All right. Thank you.
No problem. Yeah, there should be. If it does work in the browser, honestly, I don't know. Typically, the network settings, so this is a computer on the internet, so maybe something wrong with this computer, like not your laptop, like maybe a problem with our laptop, maybe a problem with I did this computer myself a couple weeks ago, so and it works. Let me try it on my laptop real quick to see if I can get it to go. Were you just using the example one that was on the?
No, I was using like the ones that I came up with to get stuff, and it comes out. So like everything that I've done comes out in the browser. It just never comes out in Perl.
Okay. Let's see here. Oh, I don't remember my key. Darn it. Ah, shoot. I have one. I just don't remember what it is. Let's see. API credentials.
Yeah, because when I try to use Perl, it just doesn't give me an internal server error.
So I want to run. It's a lot of text. It's a lot of text.
Yeah, I mean when I run it through the browser, it works fine. But I want to figure out what's going on with Perl that makes it not show up. That's what I figured. I figured that maybe Perl just doesn't work. No, it works for you.
Yep.
So what?
Check. I mean, maybe check your key. Maybe you didn't copy. Like I know sometimes I forget to copy the last letter, or.
But wouldn't that cause it to not work in the browser window?
Yeah.
Like I would assume if it works on one, it would work in the other.
I mean, I could. Yeah. Oh, that's not the thing. I would assume so as well, which to me speaks to it being, gosh, what is this? A computer issue either on the IDE end, yeah, probably on the IDE end more than likely. You could try to restart the, huh? Oh, I copied the curl, I didn't mean to copy the curl. You could try restarting the, yeah, it works for me too. You could try restarting the IDE, see if that helps.
Okay.
It's got to be on the IDE side. If it's working in the browser, it's something with the IDE.
Okay.
That's all I can think of.
Okay. Like,
Yeah, yeah, absolutely. Through the browser, sure.
So, I heard you guys talking about it. Is there any particular reason why this format is different in the browser than the IDE?
Terminal just doesn't handle formatting very well. That's the biggest reason.
Okay. Yeah.
Maybe it's already activated. Have you tried going to the site and seeing if you can log in?
No, I haven't actually.
Might have gone through. Might have worked. So you might be able to just log in. Go to documentation. You actually want scroll down a bit. The docs one. Yeah, you want right here. I'll do it.
Yo, for the first question, do you really want them to copy? They said what items were on the menu for breakfast yesterday. I thought it was like write the request for that, but is it? You actually want all the items to copy and paste the whole thing?
Does it say to copy and paste the result? I thought it said to copy and paste the request.
Go up there. To form
To
requests.
form requests.
Yeah, maybe.
So this is what I want them to answer. How did they make a request that does that? And then I want them to put their requests into the file, not the answers. Just
Do you want to do a little? I feel like other people are gonna have that same thing. Maybe just make a little brief announcement.
Just real quick announcement about the studio, since I've already had a couple questions about it. When you go to submit to Vocarium, I don't want you to submit the results. That's not what I want. That's a lot of stuff. I want you to submit the requests. So the HTTP, right? That's what I want you to submit to Vocarium, not the actual data itself. I don't really care what's on the menu for breakfast. Okay? Yeah.